Hello guys, how are you doing? You guys are awesome. Thank you very much for the recent feedback you guys send me on my social media regarding what I can do in this channel, what I should do more and what I should cover. Thank you very much. So regarding Kafka, we have done two videos now. We discussed what are the Kafka use cases and we discussed basic Kafka setup. But here's the problem. So these things are awesome, right? These things are easy and cool, but the problem comes when we are using those on our project, because project use cases are not in line with exact this happy path what people, including me, describe in the YouTube videos, right? So that is why most of the time I'm trying to cover edge cases and advanced cases on YouTube videos, because we need to deal with reality, right? So we are not university students, we are not college guys, we just professional people who work on industry, right? Things should be professional. So today I am going to cover something like that. I'm going to show you how you can customize this configuration, how you can meet some advanced use cases through this Kafka. Okay, so basic setup is fine for the kind of a standard project, small project, but when the project is bigger, when you have large scale enterprise solutions to work, that standard out of the box solution will not fit. So you need to do a little bit tweak configurations to get that done. That's what you're going to do today, right? So let's assume we have a topic, right? Let's say with the 10 partitions, so 20 partitions, doesn't matter how many. And then let's think about something like a disconnected microservice pattern. Okay, so we have three different services. They publish their events to the Kafka, and then people who are interesting, they will listen to those. Okay, if you know about the Saga pattern, something similar to that. So what's the advantage of that? Then we can handle complete decoupled situation. But when we process messages through the consumers, the confusion a lot of people has, what if the message is lost? What if we couldn't process the message? What if I lost the message, but then the Kafka doesn't know I lost it or something like that? So those are a little bit advanced use cases, right? So let's go and see how that works. First, make sure you subscribe if you're not subscribed yet. And of course, you're going to like this video. So just click the thumbs up right now and then go to the video. All right, so first thing is how we can process messages as a batches, not as a single one by one messages, but how we can process as a batches. Okay, so this is our usual project we tried last time. Okay, so if you come here, you can see you have a consumer.run and then inside the each message, right? So instead of the each message, you can use something called each batch, right? So if you go to this each batch, you can see, right, it's a batch handler. So now it's asking few batch payload configurations, right? So you can set the resolve offset, you can set the heartbeat, which is important. I will explain what that is. And then also uncommitted offset is running, is stale. So you can give a few more features than what you had on this event, this one, right? Each messages you do, we didn't have such things. Okay, so if you go here, we don't have that much of parameters. But so if if you want to handle the as a batches, you can find examples in the Kafka.js website, and you can prefer those and you can use as a batches. There's no problem with that. Sometimes your use case will fit to that. Keep in mind that's a little bit advanced than the processing each messages. But now is the but come. Okay, that being said, you need to understand this. Though you write this each message in your project like I did, right? I have used each message. Though you have done that, keep this in mind. This client will process the message as a batches. What they have done is they take the messages as a batch and then it process one by one in the each message, right? This doesn't mean you're pulling one by one messages from the Kafka, right? It means you press the batch, you fetch the batch and you process the batch. At the end of the batch, what it does is it commit these messages back to the Kafka. Remember, the Kafka use something called consumer offset. We discussed in the last video, right? So let's say there's a consumer 1. So now in the consumer offset is 98. That means the 98 message is to the read, right? So now 98 message is pushed to the consumer. consumer read it and commit the offset, does now it will be 99. It will be 100, right? Now if the consumer start again, consumer will consume from the 100 message, because that is the last read message. It's like something, you keep the record about what was the last message I gave to this consumer. Something like that. Very simple, right? No, nothing advanced. Now, what this does is, every time it in the batch, it will submit the last consumer message or last offset or something like that, right? Not something, last consumer offset. So, not the last consumer offset. It's like last final, something like that. Okay, anyway. Now, if you, let's say you get 500 messages at once, right? So what if the 400 messages crashed, right? Then it will send everything again, because you didn't submit the commit. So for that, to avoid that, you can use a property here, right? We can use a property here called auto commit threshold. So that means once it reach, if you say 10, once it reaches 10 messages, it will send the commit offset back to the server, right? That means each and every 10 messages it's sending, right? Or else otherwise there is other property called auto commit interval. You can set this as well. You can say every 1 minute, make sure you commit this back to the what is the consumer state to the server. So let's say now you got the 500 messages. Every 100 messages you are committing. If you crash on the 150th message, then first 100 will be committed, and then it will reprocess the rest of the things. Okay. However, you may not want to do any of this, right? Maybe you need to commit one by one messages to back to the Kafka. That's okay. You can do it, but when you do that, you need to be careful, right? Everything comes with a cost, right? If you look for a more easy, flexible solution, it has its own cost. Now what happened, each and every message, you're sending a message back to the Kafka, right? It can impact on your throughput, because the Kafka is busy sending the messages as well as the getting the commits, right? Okay, anyway, I'll show you how to do it, okay? So how you can do is, you can set auto commit equal to false, right? When the auto commit set to the false, Kafka will not handle the committing part. Anything automatically, you need to manually handle the commit process. That means you got the message, you do your task, right? If it is success, you can say, hey, I'm done with this, so you can commit it. And then if you didn't commit, the commit offset will be remain. Okay. So now what you need to do is, but we need to be very careful. I'm going to explain the problem this causes with the heartbeats and the timeouts at the end of this. Okay. So for now, let's try something like this, right? So I'm going to handle the commit manual. Okay, so await consumer.commit offsets, and then we need to pass what is the topic is, right? And then we need to pass what is the partition, and then we need to pass offset. So number, and then I can say message.offset, and then this would be a string because the commit is a string, and then I can use this. Okay, right? So let me to explain what this is. Now how this works is, if this message is completed, and then it will get the particular topic partition, and then we set the offset back to the server. Okay, right? So now if everything is done, we can get this work, right? But purposely I made a problem here. Okay, I will explain what that is in a while. So now ideally, if we crashed during this processing, it should retry. Okay, but see what happened. Okay, see what's going to happen. What I'm going to do is, let's say this process take let's say 1 second or 2 seconds to process. Okay, let's do something like this. Let's write some manual here. Await new promise, and I got the resolve, and I'm going to use set timeout. Okay, and I get the resolve, and after let's say 1000 to make it simple, right? So now what this will do is I get the message, and let's say this is the processing. It take 1 second to process and then commit the offset. Okay, so this will code, and now that means we need to print everything after one by one. Right, so let's run this node consumer.js. So now it's listening to all the three partitions. So meanwhile let's go here and create our producer. Okay, and node producer. Okay, it need to go to Kafka demo and node producer. Right, it produced the messages. If we come back here, oops, there's an error. It's saying each message employee topic not reduced. Okay, so I missed to add, this should be an array, so I missed to add the array. Okay, let's save that and run this again. Okay, so now you can see it print all the 10 messages, right? So now see what I'm going to do. I'm going to fail this on purpose. Okay, how I'm going to do this, like say 359. Okay, let's say 362, right? If the offset is 362, I'm going to break this, right? If message dot offset equal 350, let's not 350, 362, right? 362, and then I'm going to throw new error. Okay, something. Okay, so why? I want to break this and see what happened to this one. Okay, and now I'm going to run this again. Right, 62 it should break, right? It broke. So now you can see here it break into 362, but starting again from the 359. Right, it's starting again from the 359. Why? Because it's starting from the same batch. Right, it's starting from the same batch. Now it will keep retry because we have a default retry level up to until that it will keep retry. But keep in mind we process this message successfully, right? 361 message we process this successfully. Okay, so now 362 message is the problematic message, right? That's the 362 message. Now it's over, right? So this now it's go to the end. Retry is over. Now see this one, right? So now I'm going to stop here because I want to show this to you, right? So this one. So now in our case, what happens is we process from 359, right? 362 is the troublesome message. 361 successfully processed, right? It keep retrying all the messages. That means this 359, 360, 361, it will keep processing multiple times because of the retry, right? Now what happens is when you come here after retry, when they start again, it processing 361 again, right? Which is successfully processed. We don't need this message to process, right? So what we can do is, first, let's solve one at a time. Let's avoid this retry. Because if you retry, what will happen? It will keep retrying all the process messages from the same batch. That's what I explained. Though you see it's a one by one messages, it's take as a batch and process, right? Okay. So now we want to stop the retry. Let's solve one problem at a time. So how we can do it, when we create this consumer, we create the retry, right? Retry. Okay, so here is object, we need initial retry time. We don't actually need this because we are going to disable the retry. Let's put a little bit. And then retries, I'm going to set as a 0. So now technically it won't retry. Okay. So first let it to clear all the messages what we messed up last time. Okay, and let's disable this. Okay, you don't need to do that, right? We can read it right here. Okay, but let me to clear it and show it for you. I'm going to disable this for a moment and run to clear the messages what we have. So now we flush the messages, right? If we start this again, you will not see any messages coming. Okay. So now what I'm going to do is I'm going to, okay, what was my last message? 362. Not the 362, right? Everything is processed. Okay, let's get set other set of messages and see. Right. So 368 is my last message, right? You can see here every time when I start this one, it get the last message, right? So now I got the 361, 368. So now I'm going to start again. Right? See, every time when I start, it give me the last message, right? It's little buggy. So now what I'm going to do is, meantime, I'm going to stop the same problem in the 372. Right, 372. Now we disable the retries, right? So now ideally, this entire batch should not retry. Okay, so I'm going to run this node consumer, and this is still, it will get the last message because we didn't fix that problem yet, but that's fine. So now, meantime, I'm going to publish some messages. You will see 368 later, and 372 it should break. So now you can see 372 it break, but again it trying from the 371. But technically, if we stop this and see, 371 we already processed, right? 371 we already processed here, right? But keep processing again. Now the problem here is this: we set the consumer offset for the last read message. For example, let's say you're processing 1 to 10. When the fifth message is fail, for success, you send the consumer offset as a 5. Now, 6th message fail, right? So it won't get any consumer offset. Now, when the Kafka retry, it sees the last offset is 5, so it sends that message again. Last offset mean not the message you last read, right? That is the message you're getting now. Right, that's the next message you're getting. That's the last offset, consumer offset mean. How we can fix this? It's quite simple. I'm going to go here and press 1 plus 1. I'm always, if I send the fifth message, read the fifth message successfully, I'm telling Kafka, hey, next time you need to send me the sixth message. Once it's success, I'm saying Kafka, hey, next time you need to send me the seventh message. Okay. So now let's see whether it would work, right? First time it won't work, right? So don't worry. Okay, so let's break this problem, and let's stop this error, and let's flush the messages, right? And now we are going to, next time we are going to stop from the 382. Okay, we are going to break from the 382. Okay, so this will go and hit until like 379 or something like that. Okay, so now it's cool. In the 382, next time we'll break. Now 382 is the troublesome message. 381 we last read message. That should not read again. Okay, that should not read again. Right, so now you do this, and let's say 382 break. Oh, it doesn't break in the 382. Why is that? Okay, I didn't stop and start, right? And I didn't save it either. Okay, it's my fault. Okay. Oh, now it should not be 382 again, right? Let's go to 392. Now 392 should break, right? So now you can see it break in a 392 message, but starting it from the 392. So we don't reprocess any messages, right? The problem solved. So now it's keep retrying, right? Because 392 is never going through, right? Because we hardly blocked it. So now the problem is, meantime, the other messages will come and queue in this topic. Okay. However, keep this in mind. So now, since this is stuck here, if you start other consumer, we'll see, let's do this and see what will happen, right? The last message we got is a 392, right? 391 is the last committed message, okay? The demo. So I'm going to start other consumer. All right. So now we'll see what happened, right? So now both nodes is trying to process 392. Okay. So both node process trying to process 392. Why? Because 392, as far as Kafka concerned, 391 is the last read message. So therefore it gives the 392 to the new consumer as well. Right. So let's assume this 392 problem we solved. Okay, 392 problem we solved, right? But still these active 2 consumers won't see that. I'm going to create new consumer. Right, I'm going to create a new consumer. See what happened. Right, node consumer. So now this guy can process 392, right? So 392 process 393, 394, and everyone there process there, right? So now if you go here, right, it processed 395, and if you go here, after 392, it didn't process anything, right? 392 got the error, and after here, it processed 392, 393, 394, right? Now you can see it's balancedly processed, right? But after that, they did none of like 392, 93, 94, and this guy only 95, right? 392 message is guaranteed only processed by one, right? Only processed by one. 392 this process, and but this one didn't process because this one, there was an error, right? That part is automatically handled. However, you need to understand this problem. 392 stuck, meantime you get more and more messages. Until you fix the 392 problem, none of the message will dispatch from the Kafka. So that will create the lag between the last produced message and the last committed message, right? So you need to understand, if you're doing this, how to solve those problems as well. The one other solution for this one, we can keep these messages in a database, right? We can keep the messages in a database, whatever the messages. So based on the last messages, you can set the seek. There is a seek property called seek, and you can take the consumer to the exact position you need. But Kafka already keeping this consumer offset, right? If we can little play with this, you can fit this to exact your use case. Okay, now that's about that. There's one other thing we need to understand when you playing with the Kafka. That is, let's say now you get this consumer, right? So now we put here 1000 second delay, right? 1000 millisecond delay. That means which is 1 second. Let's assume your process take 5 minutes to complete, right? Let's say your process take 5 minutes to complete. So when you create a Kafka client here, right, there is a property called session timeout, right? There is a property called session timeout, right? This one. So this session timeout. So this session timeout is important. Why? Because based on this only, this rebalancing works, right? So now let's say session timeout is 30 seconds. You did not send the heartbeat within the 30 seconds. If you did not send the heartbeat within 30 seconds, what will happen is this consumer will detach from the Kafka. Remember the rebalancing, right? The Kafka thing, okay, this guy is not responding to me, right? So especially when you're dealing with a framework like a node, you need to be very careful. Why? Because if your process take more than 30 seconds, more than the session timeout, then your heartbeat signal will not reach the server. As a result, you will be released from the cluster, right? To avoid that, you can put two solutions. One, you need to increase the session timeout, right? Let's say your process take approximately 3 minutes. You can set the session timeout to the 4 minutes, right? But that create other problem. If in case consumer dead, really dead, then load balance, the rebalancing will not happen until that time interval. So that's a little bit disadvantage. Or else what you can do is, you can keep the session interval as low as it configured, or some reliable amount. And from here, each message you can take the heartbeat, right? Heartbeat as an input. And then after everything, you can call this heartbeat, right? You can call the heartbeat. What the heartbeat does is, heartbeat tells server, hey, I'm alive, right? So my heartbeat is working. So that is what this heartbeat means. So you can call this heartbeat during your process. Let's say you've done one thing, and then you call the heartbeat, and then you do something, you call the heartbeat, something like that. So that way you can keep the session timeout in the lower as possible, and then not the possible means not the 1 second, 2 seconds, but the desired amount, and then still you can stay in the cluster without detaching from that because of your long running task. Okay, that also you need to take care of. As a summary, what you need to understand when you are dealing with the manual commits, manual consumer offset commit, you need to make sure you are not retrying the messages. You should be ready to get the messages again and again within the same batch. That's one problem to solve. You can disable the retry for that, but when you disable the retry, it will stuck on the same message, and then until it's all, it won't go. And if you stuck in the same message, your lag will grow, right? And there are a few things you need to understand. And also, if you have a long running processes within your after your consumer comes, then again you need to make sure you are not create the problems for this session timeout and the heartbeat interval, right? So then if you can do this, if you can understand this, and if you can customize this the way you need, you can get really maximum output from the Kafka. And if you need me to cover something, some edge cases like this, just put a comment and or reach me in the Facebook asking your particular use case. If I think it's a valid use case for like majority cases, if I think it's some problem most of developers facing, then I can take it and demonstrate like this with a solution. Okay, then stay safe, take care, make sure you subscribe.